Here's a wild stat. At 700 meters below the ocean, the pressure is about 70 times higher than on the surface, enough to turn a hollow concrete ball into a giant rechargeable battery. Today, I'm diving into ocean batteries, how we can store clean electricity under the sea and power entire cities from the deep. First, the problem: wind solar don't always show up when we need them. We need big, cheap, long-lasting storage, and the ocean gives us something priceless for free: pressure. Lots of it. System 1. The pressure-pumped hydrosphere. Picture a massive concrete sphere on the seafloor with a turbine and a pump. When there's extra wind sun, electricity pumps seawater out of the sphere, creating an empty chamber. Later, when we need power, the ocean pushes water back in through the turbine, generating electricity. It's the same idea as mountain reservoirs, just with Mother Nature's mountain being the water above you. Projects like STEN-C tested this with concrete spheres and found deep water makes the numbers work even better. System 2. Underwater compressed air. Think giant anchored balloons, rigid tanks. Extra electricity drives compressors that stuff air into those chambers. When you release the air, it spins a turbine to make power. The magic is the stable cold environment, constant pressure, which can make the system more efficient and long-lasting compared to on-land versions. System 3. Buoyancy batteries. This one flips gravity storage on its head. You use electricity to pull floats' heavy weights down to the seafloor, storing potential energy. Let them rise, and they spin generators on the way up. It's like a yo-yo, but the string is a power cable. There's also the ocean battery approach from the Netherlands: seabed reservoirs, small turbines near offshore wind farms. Excess wind pumps water into a higher pressure chamber underground. When the wind drops, water flows back through a turbine, delivering steady power right where the cables come ashore. Why do this underwater? Materials are simple: concrete, water, air. The systems can last decades, store for hours to days, and sit next to offshore wind, cutting transmission peaks. No lithium, no rare metals, inherently fire-safe. What's hard? Saltwater eats everything, so coatings and corrosion-proof parts matter. Maintenance at depth is tricky, so designs need modular parts you can swap at the surface. You also need to map the seabed carefully and protect marine life and habitats. Timelines. Prototypes have already run in lakes' coastal waters. The next step is pairing ocean batteries with big wind farms to smooth out day-night and weather swings. Think of it as a giant, quiet, underwater flywheel for the grid. If this scales, cities could run on wind and sun, buffered by the deep, clean power, on demand, without building new mountains of batteries. So next time you look at the ocean, imagine it quietly breathing in and out electricity. That's the future humming under the waves. If you learned something new, hit like and subscribe.